So let's go back to our Vagrant file. Here it did not work. This is because it requires a few roles from Ansible Galaxy. Let's install them first with the command Ansible Galaxy install. Roles are given in this file, roles.yaml. So -r roles.yaml, where to install in the directory roles. And once we do this, we will be able to bring up node 1 and provision it again. I'm giving this provision flag because it already attempted a provision and the provision failed. So it's not going to try again until I explicitly call for it to provision. So what this is going to do is this is going to install Docker, configure Docker, and install the kube tools, kubeadm, kubelet, those tools. So this is going to take some time for Docker to download and install. Okay. Until then, or we'll just wait for it. Okay, so our node 1 is ready. We will be able to SSH into node 1, and we can see that this is our Vagrant node. So Vagrant at node 1. Okay. Now the first thing we'll do is create a simple Kubernetes cluster. So using kubeadm init, that's it. Kubeadm init is going to initialize the cluster. But it's good. So for the first time, it's going to download the images for the control plane. I normally like to do that first. So let me do that. Sudo kubeadm config images pull. Okay, so now that we have pulled the images, we can say sudo kubeadm init, and this is going to initialize a cluster of Kubernetes or this server as a single node Kubernetes. It's not going to take much time. Okay, so that's about it. Now we can use the kube configuration that is present in this location, but it won't be accessible as a normal user. So let's copy this in this default location for kubectl so that it automatically picks up this file. So mkdir dot cube slash dot cube, this is the directory, sudo cp etc kubernetes admin.conf to the cube directory, and chown vagrant, which is a user, the current user, dot cube slash admin.conf, and we have to rename that file also. So mv cube admin.conf to cube config. Okay, so kubectl get nodes, you can see that this node is present here. Now this node, you can see the status is not ready. This is not going to be ready until we configure an overlay network. And in order to do that, we can visit this link here. And Calico is my network of choice. So we can apply this using this kubectl apply this manifest for Calico. And after some time, the status is going to change from not ready to ready. Okay. But the thing is, this is a default configuration of Kubernetes. A couple of changes. The first thing, it does not include any authentication, no integration with identity provider, and it does not have RBAC enabled, which is role-based authentication, which means any user who gets access to the server can change anything in the server, right? So these are the two things that we really need to change. And in order to do that, let's go to Kubernetes documentation on authentication. Okay, so authenticating Kubernetes. Let's also, before we do this anyways, we have to create the cluster again. So let's destroy the cluster also using sudo kube adm reset. So this is going to stop all the containers in the control plane, and we also need to clear the etcd files here on the system. So the location is var lib etcd. Let's remove this also, and now we'll be able to create the Kubernetes cluster again. Okay. Now the next thing that I'd like to do is instead of simply saying kube adm init, I would like to provide a cluster manifest or the cluster configuration in the form of a YAML file. And if I need any changes, then this YAML file, I can make changes in the YAML file, and this is something that I can check into the repository also. So the first thing we can do is say kubectl config print, kube adm config default. Okay, I forgot the command. Kube adm configuration file example. This is obviously not the place. Let's see here. Yeah, so this is it. Kube adm config print default. So let's do that. Kube adm config print default. Okay, so this is the default configuration file. Let me write this inside cluster.yaml. Okay, and inside this we have to make a few changes. Okay, so the first thing is advertise address is what we have to change. So the advertised address should be the address of this virtual machine, which is 192.168.111. You can check this in the Vagrant file. The bind port, let it be 6443. And the other changes we need to do is in the form of extra args for API server. That we have to do in cluster configuration. So here you can see the line kind cluster configuration. So inside this configuration, after this triple dashes, this is where we need to do our configuration for API server. Okay. Now, if you look here in this file itself, we should have some example of how to provide extra configuration. Or what I'm going to do is I already have a sample file written. Let me check the configuration there itself. So cat vagrant samples oidc cluster.yaml. Okay, so here inside API server extra args and then provide the oidc configuration, right? So let's do that. Cluster.yaml inside API server extra args and then provide the extra arguments here, right? Which extra argument? This is given in the authentication documentation in a table, which you can see over here, right? So let's start providing this information. OIDC issuer URL. Let's put that. How do we get the issuer URL? Go to Keycloak, not the 8080 port. The Keycloak with HTTPS. Make sure this address is like this because the endpoint configuration that we will see will have the domain name of whatever you're visiting. So do visit with this domain name. Okay, and then here you can see the issuer. So copy this issuer and where are you? Okay, here issuer URL. This is the issuer URL. Okay, what is next? The client ID, right? So for this we have to create a client in Kubernetes. So let's go to the clients part and click on create and create a client ID Kubernetes-client. Save this. So Kubernetes-client is now the client ID. Let's put this. What else is required? Username claim. So this should be the username. I'll help you understand what this is. Username prefix. What should be the prefix for the username? This we can give it as dash because the value of dash disables all prefixing. Okay, or if we want some prefix to happen, then we can use it. So for the time being, I'm just giving it as dash. And OIDC groups claim. And groups prefix. Okay. Now this username claim, groups claim, and groups prefix is something which we need to provide here. Now, in order to, before I do this configuration, let's understand how to get these values, or how to. Now, I could tell you a way in which you can just remember some rules and provide this information, but then you might, if you had to debug, then you will not be able to do it. So let me take the harder approach, in which we are going to find out and make sure these values are correct before we even set it. Okay, so how we are going to do that is, since we have already installed Keycloak, we are going to generate an ID token from Keycloak. So this ID token will actually be used by any of the clients in order to authenticate with Kubernetes. Okay. Now, in order to do that, we need to know the URL for this. I remember opening this here, and here you see the token endpoint. This token endpoint is what we need to copy. Okay, so do a curl -x post, do a post on this. So the first error we see is that the SSL certificate problem, right? Because this is self-signed, this host is not going to trust this certificate. The same problem will happen with Kubernetes also, which is if we were to point Kubernetes to this instance of Keycloak, it is not going to accept it because it does not trust the certificate. So what we have to do first is fix that problem. We have to make Kubernetes, or rather we have to make this virtual machine accept this certificate or trust this certificate. Okay, so here this virtual machine is a Debian virtual machine. So the way to do that is to copy this file, which is vagrant certs tls.crt. Okay, copy this to the location user local share CA certificates. Use sudo and then run update CA certificates. Okay, so you can see that one certificate has been added, right? Now if I were to run this curl command, it does not complain about the certificate, but actually the request has been made, it reached the server, and the server responded with an error description saying missing form parameter grant type. Okay, so I am able to reach the server. Now we have to provide some more information to get the token. Okay, so what information is required? First, grant type. We can use password only for testing. We don't use password for production. We can provide the client ID, which is Kubernetes client. Provide the username, which is admin, and password, which is password. Okay, so this gives a JSON here, and this JSON includes an access token that you can see here and a refresh token which you see here. But Kubernetes requires an ID token, not access token. So in order to do that, we are going to modify this request and set the scope to openid. The moment we do that, here you can see that there is an ID token. Okay. Now, if you look at this ID token is a string which contains 3 parts. Let me show you in a code editor. So it contains 3 parts. Each part is separated by a full stop. So let me separate them in lines. So this is one part, this is the second part, and this is the third part, right? The second part is which contains all the information of this token, right? And this is base 64 encoded JSON. So we should be able to run atob in our JavaScript console, provide this the second part and hit enter. Then we can see what data is provided here in the form of JSON. Yeah, so let's look at what is present here. Subject is one of the important things here. Subject identifies who is authenticating with the server. So this has UUID here of the user, but this is not the username. So here we have preferred username as admin. So this is the username, right? So when it comes to this field of OIDC username claim, we can give here preferred username, which is this one. Okay, so this is the preferred username. Username prefix is hyphen, group claim and group prefix. These are the 2 fields which we have to figure out now. Okay, now when it comes to group, groups are a way of providing RBAC permissions. So if we want to provide any sort of permissions to a particular user, instead of providing it directly to a user, we can instead create groups and provide these permissions to groups and then add or remove users to one or more groups. Okay. Now for this to work, this token also needs to identify what groups the user is part of. Now in order to do that, we have to do some configuration in Keycloak. So let's get there. This is our Keycloak. First of all, let us create a group. I'm going to create a new group called admin. Okay, now in this group, I'm going to map this group to one of the client roles, okay, in Kubernetes client. But there are no client roles, so let me just go ahead and create a client role, edit the Kubernetes client, go to roles, and then create an add role called admin. Okay, so and let's go back to the group, edit it, and in the role mapping, let's map it to the admin role. Okay, so basically what we did is we created a group called admin, and we created a client role called admin. So this client role is what we are assigning to users of this group. Okay, now this user, okay, so this user is already part of this realm. What else do we need to do? Okay, we have to add the user to this group, right? So how do we do that? Let's see, can we edit, go to members? Yeah. Okay, so this says there are no group members. So let's go to the user. Here is our user, edit the user and add him to a group. Join. Okay, so now the user is part of this group, admin group, and the admin group is configured with one of the admin roles, with the client roles of admin. Okay, fine, all this configuration has been done, but our primary problem is the group's information needs to come in the ID token, right? That is not present here. So what we need to do is configure a mapper for this inside our Kubernetes client. So let's create a mapper by the name of groups, and we want to map user client role, okay, for Kubernetes client. Okay, so the client role prefix would be let's say Kubernetes colon, okay, and the token claim would be, no need for all of this information, I believe. So this client role prefix we have given, I think that should be enough. Okay, so let's just save this. Oh, I think we need a token claim name, correct. This is the key of the key that appears in the claim. So let's just save this. Okay, now groups will be the key, and the value will be Kubernetes colon and the group which the role which the client role which this user has. Okay, now let's quickly generate another token. So here it is. Here is the ID token that you can see, and let me again paste it here. Take the second part here, and within my browser, or preferably in a new, preferably in a new tab, say a top, and paste this. And now you can see that this groups has appeared, which has Kubernetes colon admin. Okay, so this groups is the name of the claim. Okay, so let's go back to our configuration. OIDC group claim is going to be groups. Okay, and OIDC group prefix is going to be let's say Kubernetes colon. Okay, now the thing is, okay, I'll explain that later. Remember that this Kubernetes colon is not the same as the Kubernetes colon which we have given and when we are configuring the mapper in Keycloak. Okay, uh, this is a way of making sure that uh, the group names or the user names that we that Kubernetes receives is actually unique across claims and across different providers, across different realms. Okay, so for that reason, OIDC clients normally have a mechanism of prefixing the group names, the claims, as well as the user names with something. So here we are prefixing it twice, once when the token is generated and the second time when Kubernetes receives it. So Kubernetes is going to append one Kubernetes colon, and our Keycloak is going to send us the group itself as Kubernetes colon admin, as we see here. So the effective group is going to be Kubernetes colon admin. Okay. Um, so that is that. So I guess all the information is set here. The other thing which we have to do is we have to enable RBAC. So let's see how to do that. So for this, let's go to the Kubernetes Kube API config or Kube API reference. Not exactly this. Yeah, so this is the one. So here we have to look for RBAC also. So authorization mode, you see this option here, authorization mode. It allows so many different options. So we are going to select RBAC as the authorization mode. Okay, so let's add this also inside our API server configuration. Okay, and now we are all set. So let's say, okay, did we add the TLS certificate? Yes, that is also important. Remember, we copied it to user local share CA certificates directly and run the sudo update CA certificates command. So that we have already done. So now Kubernetes should not have any problems speaking with Keycloak. Okay. Now let's go ahead and say kube adm init and provide the config file. Okay, there's some problem here. So let's look at it. It says the problem is in line 8. I don't know why it is giving a problem here because I don't remember changing anything, but okay, so let me quickly do a diff between this file. And my file. So you say just signing authentication, this doesn't show any problems here at all. So okay, OIDC issuer URL is still there, OIDC client ID is there. Okay, maybe it is line number 8 in the second part of this YAML. So let me try to go there. 1 2 3 4 5 6 7 8. Okay, here is the problem. This has to be inside quotes. Okay, now let's try it again. Line number 10 now. So this is 1 2 3 4 5 6 7 8 9 10. Okay, maybe this also has to be in quotes because of the colon and in the end, right? Okay, since we are now using the cluster YAML, even the Kubernetes version should be in under our control. So it's trying to install version 1.14. If you recollect the logs previously, when we did not use a configuration file, it was using 1.15. We also pulled the images for version 1.15. So we need to change this now. So where is it using Kubernetes version? Let me search for version. No, not there. 1.14. Okay, here it is, Kubernetes version. So I'm going to change this to 1.15 and then try it again. Okay, so there you go. Let me now remove the old config file. And in fact, I'll not put the config file here because this config file will give me admin access to the cluster. But then we have to authenticate as a user that we created in Keycloak, right? So that's why I'm going to copy the cluster configuration in my home directory. So sudo cp etc kubernetes admin.conf. I'll copy it here and own it also. Okay, so here you can see the admin.conf. So if I say kubectl get nodes, it's not going to work because there's no configuration here. Instead, I have to say kubectl kubeconfig admin.conf, which is provide the kube configuration file, and then say get nodes, and then it works. Okay, right. The second thing we have to do is configure Calico. So here it is. Let me do that quickly. Okay, again for this command also we have to say kubeconfig admin.conf, right? And this has applied it. Now if we say get nodes, after some time the state will become ready. Okay, so you can see it is ready now.